Today we're going to be interpreting graphs and function notation word problems. So the first thing we're going to do is look at that graph here and interpret what's happening. So this uses our function notation or finding information from a graph that we've been doing recently. And so the first question that it's asking us is, where does f of x equal g of x? So here's your f of x function. This line is f of x. And this line here is g of x. And it wants to know, where does f of x equal g of x? Well, here, this is the y value, right? F of x is the same thing as y. So we want to know, where does the y value of the f of x function equal the y value of the g of x function? Well, we're looking here, and these two functions are the same at this point where they cross. Where does the y value of the f of x function equal the y value of the g of x function? So we're going to answer out an x value. So this is going to happen at x equals 2. At that point, the y value of the f of x function is 5, and the y value of the g of x function is also 5. The next question asks us, what is f of 4 plus g of 4? So with that, this tells us that we have x equals 4 in the f of x function, and this is telling us x equals 4 in the g of x function. So we got to be careful which one we're looking at for this. Okay, f of 4, we're going over to 4 and then up to the f of x function. So I'm even going to use a different color for this one. So here we are at f of 4. We follow it up to the f of x function, and that's going to give us a value of 7. We're going to add to that what g of 4 is. So we're going to x equals 4 in the g function. So x equals 4 up to the g function. That y value is 6. So if we take 7 plus 6, we get 13. So that is our answer for that question. The last part for this one says, which is bigger, f of 3 or g of 5? So since we have f of 3, this means x equals 3 in the f of x function. Okay, so we're going over to 3, and in this top line is our f of x function. So that is 6. G of 5 means x equals 5 in the g of x function. So we're going over to 5, following it up till we get to the g of x function. And that right there is a little bit more than 6. So let's say it's 6.2. So which one of those is bigger, 6 or 6.2? So 6.2 is bigger, so here we would answer g of 5. That's the bigger thing between these two pieces. Next, we're going to be interpreting a couple of different word problems and what they mean. So it says for each situation, either create a function or use the given functions to find and interpret the solutions. So the situation that we're in, Fran collected data on the number of feet she could walk each second and wrote the following rule to model her walking rate. D of t equals 4t. So what does this mean? D of t equals 4t. It says that she collected data on the number of feet she could walk each second. Okay, so this means that t is going to stand for time. What is our time? So t equals time in seconds. 4t is going to be how much she walked, the number of feet she walked in t seconds. Okay, so d of t equals number of feet walked in t seconds. Okay, All right, so what is Fran looking for is she writes d of 12 equals, and then obviously she would have to figure out what that is. Here, this inside the parentheses tell us that t equals 12. And so time is in seconds. So here, since this is what t equals, this would be how far or how many feet she walked in 12 seconds. Okay, so if she were to actually plug in 12 to this equation, she'd plug it in for t and then multiply that by 4 to see how many feet she walked in 12 seconds. Okay. Next one, in this situation, what does d of t equal 100? Since this is after the equals sign, that's telling us that it's our ending result. Okay? Our ending result, which means 100 would be the number of feet. We don't know what t is, but this would be telling us how many seconds to go 100 feet. Since we know that ending result of 100, that's how many feet she would have, or that's how many feet she walked. We don't know how many seconds. All right, part C, we want to use the function rule. How can the function rule be used to indicate a time of 16 seconds was walked? So 16 seconds, is that our variable that we'd be plugging in, the input value, or is that the output? So input is in time, output is in terms of feet. So here we would say d of 16, since this is telling us that time was 16 seconds, t equals 16. So d of 16 equals some number or some equation there. Okay. Last one, how can the function rule be used to indicate that a distance of 200 feet was walked? This here is our end result. So we don't know how many seconds, so we're going to leave it as d of t equals 200. But we have to talk a little bit here about what we know about our options for t. Obviously, we don't need to solve it right now. But with this, we do know that time has to be greater than what? Well, time has to be greater than 0 seconds, right? We can't have a negative amount of time happening with this. So in this situation, we could write the equation d of t equals 200, but t has to be positive. All right, we're going to use the situation given to explain the meaning of a statement in everyday language. So you put a yam, what is a yam? Sweet potato, in the oven. After 45 minutes, you take it out. Let f of t be the temperature of the yam t minutes after you placed it in the oven. Okay, so f of t is the temperature, t is the number of minutes after you placed it in the oven. So time is going to keep ticking here as soon as we place it in the oven and beyond. Okay? So f of 0 equals 65. What does that mean? This number inside the parentheses, this stands for t. So our time is 0. This 65 is our output, which would be the temperature. Okay? So this means when you placed the yam in the oven, it was 65 degrees Fahrenheit. You could have also said at time 0 or at 0 minutes, it was 65 degrees Fahrenheit. Something like that. You don't have to say those exact words. Okay? F of 5 is less than f of 10. What does that mean? F of 5 is less than f of 10. So here, this is telling us that time is 5. Means 5 minutes after you have placed this in the oven. And f of 10 means that t is 10 because t is our input variable. And so this, if t of 5, or sorry, if f of 5 is less than f of 10, this tells us that the temperature of the yam 5 minutes after you put it in the oven is less than the temperature after 10 minutes. Okay, so that makes sense. When you're putting something in the oven, 5 minutes after you put it in the oven, it's going to be warmer than it started. And after a total of 10 minutes, so 5 more minutes have happened, you would expect that that item would be hotter than it was before. So I'm going to kind of separate some of these things out here. Okay, so that makes sense. All right. F of 40 equals f of 45. F of 40 means that the time after we placed it in the oven is 40 minutes. And f of 45 means that the time after we placed it in the oven was 45 minutes. Remember, after 45 minutes, we take it out of the oven as well. Okay? So this means the temperature, I'll abbreviate a little bit here, the temperature of the yam 40 minutes after you put it in the oven is equal to the temp after 45 minutes in the oven. So that means that those last 5 minutes, the temperature of that sweet potato, of that yam, didn't change at all. Or, if that's the case, yeah, so that's what that means, sorry. All right, f of 45 is greater than f of 60. F of 45 is greater than f of 60. So this means that our time elapsed is 45 minutes, and here our time elapsed is 60 minutes. Remember, you took it out after 45 minutes, okay? So this is going to say if the temperature, if f of 45 is greater than f of 60, this means the temp of the yam after 45 minutes in the oven is greater than the temp 60 minutes after going in the oven. So why would it make more sense, or why would this make sense that the temperature after 45 minutes is greater than the temperature of 60 minutes? Well, after 45 minutes, we took that out of the oven, and so now it's starting to cool down after you've taken it out of the oven.